Okay, so Professor Chiranjit Sain received BTech in Electrical Engineering from Maulana Abul Kalam Azad University of Technology, West Bengal, and MTech from National Institute of Technical Teachers Training and Research, NITTR, Kolkata, India, under Electrical Engineering Department. He he has completed his PhD in electrical engineering from National Institute of Technology, Meghalaya, India in 2019. Presently, he is working as an assistant professor in the electrical engineering department at Gani Khan Chaudhary Institute of Engineering and Technology, GKCIET, Malda, a centrally funded technical institute, CFTI, under Ministry of Education, Government of India. He has associated with Siliguri Institute of Technology, Siliguri, India during 2010 to 21. Dr. Sain is a fellow IET, senior member of IEEE and lifetime member of Institute of Engineers India Limited. He has about 12 years of academic experience, 8 years of research experience, and 1 year of industrial experience. His present research of interest include electric vehicle technology, digital control of electric motor drives, renewable energy integrations, etc. He has published more than 40 papers in the international level journals, conferences, book chapters in the relevant field. Additionally, he is guiding 4 PhD scholars in jointly collaboration with NIT Mizoram. He is presently serving as an academic editor of PLOS One International Journal and reviewer of some reputed journals like IEEE Transactions, IET, Elsevier, Taylor and Francis, Indecence Publications, etc. So it's really happy that Professor Sain is with us. So I'm requesting sir kindly share your slides and please start the session, sir.
Yeah, okay, yeah. Well, I would like to express my sincere, the gratitude and thanks to the entire, the management of, the NIT Rourkela for inviting me in this prestigious FDP program. Let me share my screen actually. Then I will try to discuss. Yeah.
So it is visible, sir.
Okay, fine.
So kindly make it full.
Yeah. Is it okay, sir?
Yes, it is okay, sir. Fine.
Oh, fine. Okay. So let me go through the basic background of this particular, the lecture topic I have. The lecture topic has been chosen in such a way that electric mobility for sustainable development using artificial intelligence or the machine learning we have. As we all know that in the 20th century, whenever we are standing, around the globe, the demand of electric vehicles are rising day by day. It has several significance for the sustainable, the development of the environment we have. As because the day to day, as we all know, due to the use of the conventional, the vehicles, the environmental, the pollutions are basically increasing day by day, and as an impact, the societal development will be a big question mark for the long-term sustainability in our the country and also for the globe we have. So in this particular lecture, I would like to discuss the impact of the electric the mobility solution for the sustainable the development, and the tools in this particular lecture that could be comprising of the artificial intelligence and some sort of the the machine learning applications. Now these are the basic contents of my lecture actually. In the first and foremost part, that first of all we must be go through the basic the background and objective of this particular the lecture content we do have. Now why electric the mobility? As I have been said earlier, that 18% of the total energy consumption in a country like India is basically employed for the transportation sector. So therefore, electric mobility solution gives us with the zero or ultra low tailpipe emissions of the air pollutants. And what happens actually due to the hello, yeah.
Yes, sir, you are audible, sir. Please
Okay,
carry
okay,
on.
fine. Yeah. Now the third part is that actually, while we have the electric, the mobility solution, it will tremendously contribute to balancing the energy demand, energy storage, and also the environmental sustainability in this context is that while we are having the transportation electrification in a country like the India, and if we could create a bidirectional communication between the electric vehicles and the utility grid we have, therefore the vehicle to grid and the grid to the vehicle, this sort of the technology gives us an improved the nature to balance the energy demand, energy storage like the battery, ultra capacitor, super capacitor. We do have the ultra speed flywheel we do have, and also with an impact of the demand in energy storage, and this could be greatly impact on the environmental sustainability, as we all know that there is a concept of the renewable energy integration we have. So with the impact of the renewable energy integration and by the employment of the grid to vehicle infrastructure, we could be able to meet the sustainable development. Last but not the least, of what I like to convey, that the government of India has been taking such kind of the promising solution to promote and integrate the manufacturing and also the adoption of the electric vehicles in India. But nevertheless, we are having some sort of the the greatest challenges we have. For an example, the charging infrastructure. The charging infrastructure of an electric vehicle is one of the mandatory the requirement, and also it is having more challenges that we need to face in the coming future. However, the government of India is expanding the lots of the the revenues, and whatever the different kinds of the planning and infrastructure we do have, we must be we must be emphasized for the improvement of the charging infrastructure, so that we can accelerate the utilization of the electric vehicles in a country like the India. Now, in this particular slide, I would like to emphasize the impact of the electric mobility solution, in which a manner we could see that there is an interdisciplinary architecture that we do have, and in this particular architecture, that we could see the energy, the traffic, the charging point, the battery, LRT, the power. So means in a smart city infrastructure, or while we are emphasizing that today's the modern world we need to have for this the smart communication network, so that electric mobility solution which can effectively meet the different subsets of these environmental the protection. for an example, if we could be having the concept of like the energy demand, energy utilization, and energy, the requirement while we are having the traffic congestion, the management, it is also being centralized by using any kind of the, the smart in a smart city infrastructure we do have. And definitely the charging points, these the charging points or charging infrastructure, they are so much sophisticatedly controlled in which a manner that we could see that in a typical smart city infrastructure, or any kind of the the smart environment, while we are having the electric mobility solution, then definitely an united infrastructure we can develop for the entire societal development. And each and every subset of this particular infrastructure are basically commonly interrelated with each other, and so that the user can have a sophisticated control over the entire infrastructure, and for the greater need of the power and energy, and also this makes an eco-friendly infrastructure in the coming days. Now, basically, the term is so-called the sustainable development is a very broad aspect. Sustainable development of a country is basically emphasizing the quality of the environment for the future generation without, without compromising the quality actually. So, the sustainable development basically comprising of several quantities and qualities, like the green energy resources. We need to have the lots of the renewable energy resources like solar energy, biomass energy, wind energy. We need to have the different sources of these, the green energy resources we need to have for the generation, and for the, the distributed, the distributed the generation capability we need to have. And the second one is the sustainable construction that we must be, the looking for civil or structural, the engineers, they are looking for these sustainable constructional features we need to have. The third one is the efficient water fixtures. It is one of the important aspect of the water system engineers, especially, they are looking for the efficient water fixtures to maintain the water level, and also the green space, and last but not the least, the sustainable forestry that we must be, the looking for. So the every portion, every part of the engineers, every parameters, and the nevertheless, a major part of the technocrats and engineering society that mostly are looking for the different perspective of these classifications to maintain the sustainable development of the environment. Now, basically, while we are talking about the electric mobility solution, so absolutely we must be go for the electric vehicles technology. Now, as compared to the conventional vehicles or the IC engine, the vehicles, there are several advantages of the electric vehicles technology. We do have first is that the lower running cost as compared to the conventional, the vehicles like the petrol vehicle or the, the diesel engine vehicles, while we are having the electric vehicles technology, and we are having the battery as an energy storage the component, and the battery can be, the charged very easily, and the battery can drive the powertrain of the, the vehicles, so that the energy storage, actually the battery that could be comprising of the different kinds of the power converter also, and so that the charging circuitry could be taking place, and we are having an electric, the motor as an electric propulsion unit instead of an internal combustion engine, so that we can say that electric vehicle possesses the lower, the running cost as compared to the increased, the cost of the petrol or the the diesel we are having. It also having the lower the maintenance cost, as because while we are having an IC engine vehicles, it is due to the presence of the different the mechanical components like transmission, gear, clutch, the bearings, so that we are having the loss of the transmission cost, and also the I mean the maintenance cost of these the mechanical parts is also getting higher. While we are having an electric vehicle type train, it could be comprising of an improved electric motor technology, and advanced power converter could be taking place. And with the advancement of the power semiconductor the devices, we are having the different sorts of these advanced power conversion, and also a control the unit we need to have, so that we could say that electric vehicle possesses the lower the maintenance cost and zero tailpipe emission. It is one of the foremost advantages we must be looking for, that while we are having an electric vehicle, the greenhouse gases are basically reduced in a very significant manner, so that electric vehicle possesses the zero tailpipe emission. And last but not the least, that government of India has been taking lots of the benefits like the tax and the financial benefits, which could be comprising of the registration charge and other charges to purchase an electric vehicle, or the rather to install an EV charging plant, so that we could say that there are basically several advantages we are having the concept of electric vehicles technology. Now, as a part of the the background over here, the global need of the electric vehicle is basically poised to increase exponentially in what has been dubbed as the electric the mobility revolution we are having. And the thing is that electric vehicles are expected to strengthen is basically strengthen the utilization of the utility grid, and help to accommodate the higher renewable energy penetration, while the maintaining the secure and stable grid operation. So this is one of the important aspect that we must be the looking for, as because the with the advancement of the different kinds of the renewable energy integration, and also there is an utilization of the the grid we are having, the electric vehicles technology, I mean the charging infrastructure we are having, the charging infrastructure, while we must be looking for, and we need to have this the vehicle to grid and grid to vehicle operation, then we must be looking for the higher the financial also benefit, and also the infrastructural benefits we are having. The country, the like the India, which has a set a target that 30% of the electric vehicle sales across the all vehicles types by 2030. So this is one of the the mission that the India is basically taking care, that by the year of 2030, the 30% of the the vehicles would be transformed into the electric vehicles, and these concept is basically the dominated by the two wheelers, and accounting for the 78% of the total vehicles. So the Ministry of the the Ministry of Power has already identified the nine, the major cities, and 11 intercity as the routes, so as the pilots to enable the EV charging infrastructure, and therefore the rapid growth in the EV, which could be the reach to the India's policy target, and which we could make the two major challenges. Now, what is the prospect actually? We must know that whatever the content I have been already emphasized, the sum of the promising prospect that we need to take care actually, as because the nationally determined the contribution, the transport initiative for the Asia, which is so-called NDC-TIA. It's a regional initiative which could be funded by the International Climate Initiative of the German Federal, the ministry. And under the NDC-TIA, one project is basically, the going on, which is so-called integration of the electric vehicles charging infrastructure with the distribution, the grid, global review, India's gap analysis, and the way basically forward. This mission is basically focused on the conducting the India and the international review on overall environmental, the related to the EV charging infrastructure, and the specific study which could be focused on the EV charging infrastructure, which could be based on the policy and the necessary, the regulatory measures and the grid integrations of the electric vehicles could be forwarded for the smooth EV adoption in the India for the ecosystem. Now, whatever the different kinds of the policies and integration we are having, the proper planning and operation of the distribution, the grid with the integration of the EV charging infrastructure. So means in a very, the broad sense, we must be looking for that while we are going for the EV charging infrastructure, we must have some sort of the planning and operation of the distribution, the grid. For an example, if we could see the grid support services from the electric vehicles to facilitate the large scale, the renewable energy integration. So means in a particular electrified transportation sector, and in a smart city, I mean the smart grid infrastructure while we are having, and we need to integrate the smart grid infrastructure into the electric vehicle system. We need to have some sort of the proper planning, and also the stability of the, the grid infrastructure is also one of the promising solution that we need to go for. So means we need to have some sort of the some sort of the standardized planning, the policies, and also the regulation, as because while we are having the grid to vehicle and vehicle to grid infrastructure, the cost of the electricity generated, that is known as the tariff we have, the cost of the electricity generation, I mean the while we are having the different sorts of the policies as per the Indian I standard, the I standard, the rules we need to have, we must be accompanied for. And the key challenges and the recommendation, we need to have the efficient, effective, and sustainable integration of the EV charging infrastructure. Now, as compared to the earlier, the background, while we are going for the classifications of the electric vehicles are classified into several categories. These are known as the battery electric vehicle, hybrid electric vehicle, plug-in electric vehicle, and the fuel cell, the electric vehicle. In this architecture, the battery electric vehicle is the most common we need to have. The battery packs we are having, and the battery, the different kinds of the battery we need to have: the lithium ion battery, the nickel cadmium battery. It could be the different specifications of the battery we are having. But nowadays the modern technology is that we need to go for the, the lithium ion battery. Yeah, I would have the concept of the lead acid battery also, but the depending the battery capacity, the battery configuration, the battery power we need to have, and the battery driven electric vehicle is the most common electric vehicle like a country like India. And while as compared to the battery electric vehicle, electric vehicle is so-called hybrid electric vehicle, in the sense is that hybrid in the sense is that in addition to the electric motor, we are having one ICE, the engine that could be a petrol engine or that could be a diesel engine. So the combination of the electric vehicle and IC engine that gives us the concept of a hybrid electric vehicle. In a hybrid electric vehicle, basic advantage is that actually the range anxiety while we are having in a commonly used the battery electric vehicle, the range anxiety that could be extended by the use of the hybrid electric vehicle. And hybrid electric vehicle basically employing the energy storage as the battery and also the fuel tank that could be there. So that depending on the need, we can use the electric motor as well as the engine that we are having. The next one is the plug-in hybrid electric vehicle. As you all know, that the electric vehicles are plugged into the uh, utility, the grid we are having, so that it could be also comprising of the battery we are having. And the last one is known as the fuel cell electric vehicle. It is the most promising technology we are here. We are having the fuel cell technology, and the fuel cell technology, as we all know, the hydrogen, the gas is used in the fuel cell tank we are having. And fuel cell electric vehicles are basically known as the zero emission, the vehicles, and the chemical energy of the fuel is converted into electrical energy takes place. Now, this is the one kind of the architecture that we are having, that we could see that the in a typical charging infrastructure, that we could see the different charging pool with a multiple number of the charging points we are having here. In this diagram, we could see the yellow line, actually the four yellow line, these are representing the charging points, and the red line is basically representing the charging connectors or the ports we are having. And here we could see the two charging stations are basically installed over here. So in this particular architecture, we could see that how a typical electric vehicle charging infrastructure could be installed over here, and the different kinds of the electric vehicles are parked very easily in a convenient the manner. And depending on the need, each and every electric vehicles can be charged by using the charging points that we are having. And the different and up and upon the successful charging, the vehicles can be the lift from the particular the area we are having. And these kinds of the charging infrastructure, the most commonly thing which I like to convey, that the as compared to the petrol pump or the the diesel uh, pump we are having, the charging station can be installed in the any places like the schools, like the offices, like the hospitals. So means while we are going to install a charging plant or charging infrastructure, it does not need any sort of the large infrastructural or special infrastructural the requirement like the petrol pump or the diesel pump we are having. So means an electric vehicle can be installed in home also, in office also, in schools also, in the hospitals also, so that the any the domestic infrastructure we can take here for the installation of the charging plant we are having. And the different kinds of the vehicles can be parked very easily, and upon the parking and depending on the need of the charging taking place at a particular the requirement, and we could maintain the entire protocol of the charging plant we are having actually. Now, in this particular strategy, we could see that the various stakeholders, like the power sector, like the public authorities, like the charging infrastructure, the mobility solution we are having, that inside an EV ecosystem, how the different stakeholders, they are explicitly interconnected. For an example, the government, the government as well as the public authorities, the power sector companies that we are having, and the others like the customers or the consumer, the utilities, the research and the development agencies, the vehicle, the manufacturers, like the charging infrastructure, charging station operators, and ICT enabled service providers. So in a typical smart way, communication and infrastructure, that we could see that in a common frame, and for the transportation electrification, that we could see that each and every portion of the society could be interconnected in such a way that, depending on the need of the environment or ecosystem, we all the stakeholders are contributing, and there is a linkage in between the different stakeholders, so that environmental sustainability as well as the demand of the energy and power that we are having nowadays in a modern deregulated environment, we could be made over here, that the different parts of the stakeholders, they are basically interconnected in such a way that, your electric vehicles, the power sector, public authorities, charging infrastructure, these all are basically contributing in a very combined, the manner, so that we could all play a vital, the role for the sustainable ecosystem, in a modern, the country like India. Now, in this statistical analysis, that we could see the regional performance is varied in such a way that the global electric mobility revolution is basically emphasized by the rapid growth in the electric vehicles, and as we could see from the year of 2017 and up to the 2030, actually, how the use and the utilization of the electric vehicles are gradually increasing day by day, and the different, the duty cycles of an electric vehicles. For an example, it could be lightweight, it could be, the medium electric vehicles, it could be heavy duty electric vehicles, like electric trucks, electric, the buses, the plug-in hybrid electric vehicle, the battery electric vehicle, so that we could say that from the two-wheeler to three-wheeler and the four-wheeler. So the different classifications of the electric vehicles and the different needs of the consumers across the various countries, the use of the electrical vehicle and the mission, which is so-called EV30 at the rate of 30, the global electric vehicle projection, that could be integrated in such a way that the use of electric vehicles is gradually implementing, and it is gradually, the rising across the globe we are having. Now, in this particular strategy, also we could say that the global stock of EV chargers, that is also increasing as compared to the 2013 and as compared to the 2019 we are having, so that we could say that 40% of, there is an increment. I mean, from 5.2 million in the 2018 to about 7.3 million in the 2019, that we could see. And the overall stock, we could see that the 6.5, the million chargers or the private chargers. So means lots of the private utilities, I mean the private agencies, they are also the using or uh, the investing the several kinds of the funds to implement the electric vehicles charging infrastructure across the globe. Now, while we are having the EV charging infrastructure classifications, now also we must be emphasized that the different classifications of the EV charging infrastructure we are having, and depending on the level of the power carrying capability that we are having, and the depending on the classifications of the power carrying capability, the charging strategies are basically classified into several categories like slow chargers, fast chargers, the rapid chargers, and the ultra, the rapid chargers. For an example, the slow chargers are basically, the rated as 3 to 5 kilowatt of the power rating, and the fast chargers are basically, the rated between 7 to 22 kilowatt. The rapid chargers are basically, the rated as 23 to 99 kilowatt, and the ultra rapid chargers are basically the rated beyond the 100 kilowatt. Now that you could see the charging points per EV in the different countries, that the UK, USA, Norway, Sweden, the Germany, the Netherlands, the Denmark, and the China. The different countries, the database are taking in this particular aspect, that you could see that the charging points that you could see over here, the charging points per EV, which is basically higher in case of the country like the Netherlands actually, as compared to the other countries, and the the next countries, the China, Sweden, they are also the contributing a lot. Now, comparing the number of the electric vehicles, the publicly available charger, the slow, fast, and the rapid chargers, whatever we have been classifying, in these three figures, especially the figure 10, 11, and 12, that you could see that the number of the public slow charging points per EV, higher is the better, that you could see the UK is the higher. The next one, that you could see the number of the public fast charging, in this case the Sweden is the highest over here. And the third one is that the number of the public rapid charging points, the higher is the better. Here the UK is basically participating the higher, I mean the higher, the range of the publicly available chargers, and also the rapid charging technology points that we are having. Now here, in this particular aspect here, I would like to emphasize a typical chart over here, and that chart, or the analysis that could be investigated, that the EV charging specifications that we are having. So the different kinds of the EV charging specifications, the level 1, the DC, level 2 AC, level 3 AC, and level 3 is the the DC. So depending on the need of the charging infrastructure, the charging specifications could be AC or the DC. The DC charging is the most fast charging, the fast charging process we do have, and each and every charging strategy could be comprising of the standard specifications like the voltage, the improvement of the power, the rating, and the type of the compatible charger that we are having. And in this particular strategy, that we could see that the different kinds of the compatible charger, like type 1, the Bharat AC 001, Bharat DC 001, the type 1, and the last one is the level 3, the DC charging, which has a voltage of 200 to 1000 volt, and the compatible charger, the technologies, the demo CCS1, CCS2. Next part is the most interesting part that we need to have. that the introduction of the G2V and the V2G technology that we are having. So in the earlier lectures, of whatever I have said, that the grid integration of the electric vehicles technology, which has been a very promising solution nowadays for the the greater need of the environment and for the sustainable the development. Here in this technology that we could be saying, for an example, a battery electric vehicle we are having, and we are having one smart grid infrastructure. So in this infrastructure that we could see that if the battery electric vehicle could be integrated into a smart grid infrastructure, and definitely during the charging and discharging processes of an electric vehicles, I mean, while you are having the grid utility and the batteries can be, while the batteries are parked, it takes electricity from the the grid, and also depending on the the need, it could take the electricity from the the grid, so that while we are having in a smart grid infrastructure and an electric vehicles charging strategy we are having, so that the excess amount of the power that could be that could be passes to the utility, the grid. And while we are having this charging of an electric vehicle, it takes some amount of the power from the the grid, and while the battery is discharging the electricity, that could be connected with the utility grid, so that the grid to vehicle concept we are having, that the EVs are providing power to the grid while they are parked, and the EV that could be a battery driven vehicle, or it could be a fuel cell hybrid electric vehicle, and a power connection to the grid is basically employing the bidirectional communication with the grid operators, and we are having the precision the metering, so that the electricity cost that could be charged at a very specific the rate, and as an impact the some sort of the renewable energy integration that could be emphasized into the utility the grid, so that the solar powered infrastructure or solar power urging station that could be integrated into the utility the grid for the greater need of the environment that we are having. Now, for an economic sense of the grid to vehicle infrastructure is basically the electricity from the vehicle to grid is not cheap when we are compared to the bulk electricity from the large power plants that we are having. So that like a the generator in a battery vehicle, it also providing the ancillary, the different sorts of the ancillary devices, and also it paid a capacity price that could be available to respond in such a way that energy price for the actual energy output, the ancillary service market is the basically sum as the capacity price and the energy price we are having. Now, in comparison with the earlier slides, now I would like to go for the the real-time analysis of an electric vehicle G infrastructure. In this particular infrastructure, that we could see that one of my scholar is basically working over here, and he has been developed a real-time ThinkSpeak from. Basically, it is based on the Internet of Things technology. That how the real-time, the monitoring of the charging, the strategies that could be taking place in a common environment. So for an example, in this particular infrastructure, while we are having the grid to vehicle and vehicle to grid way of the communication, how the real-time data, the monitoring could be taking place. Here the data basically comprising of the grid voltage, grid current, grid active power, grid, the reactive power, the battery state of the charge, the battery current. Now here in this particular strategy, we are having one bidirectional converter actually. That bidirectional converter, we are having one particular switching, the logic. That switching logic is basically a particular strategy that the user has to fix the particular switching, the strategy. And one AC to DC converter is basically implemented over here. That AC to DC converter is basically connected with the DC to DC converter. That could be buck boost, or it is a combination of the buck boost converter. So that depending on the level of the voltages, that the power electronics engineers are basically the looking for the design of these different kinds of the DC to DC converters in this particular strategy to meet the battery voltage that you are having. And the output of the DC to DC converter is basically connected with the switching unit 2. Now the switching unit 1 and switching unit 2 is basically playing a very important the role, while the real time monitoring of the charging parameters in a grid to vehicle, or in a vehicle to grid infrastructure, that we are having a battery, EV battery. For an example, the EV battery, different sorts of the battery strategies, especially the battery state of the charge we are having, the battery energy consumption, the cost of energy we are having. And what happens actually, while this particular switching logic is basically taking place, and we are having the the design of AC to DC converter, and this strategy is connected with the DC to DC converter, and particular output of the DC converter is connected with the switching unit 2. And depending on the switching unit 2, the battery unit EV battery is basically capable to meet the desired level of the voltages, and the battery energy absorbed or discharge. That measurement could be taking place, and time of usage based the real time monitoring, all the data sets are basically placed to the cloud, and some sort of the data are the basically uh, stored in the cloud. And IoT technology, like in a in a real time platform, the ThinkSpeak technology is basically implemented, and it is basically connected with the MATLAB Simulink environment through the graphical user interfacing in a technology that we are employing the real time monitoring, so that each and every parameters of the charging strategy, like the and one part that I was missing for the grid actually, the grid, all the data sets are basically connected with the the grid. And depending on the utility of the grid, the rate, the cost of electricity generated, and the time of usage based pricing, that is so called the dynamic pricing, that could be emphasized in a particular environment. And this technology is a very promising technology of electric vehicle charging infrastructure, interconnected with the vehicle, interconnected with the the grid, so that if we could implement one the real time platform, the workspace, and if we could connect that the data set that could be fetched from the the cloud, and some sort of the the data sets are basically stored over here, and we could integrate it actually. And so as an impact of the IoT based live data monitoring process, the results could be taking place in the the real time workspace, that we could see the state of the charge, the battery, the state of the charge that we are having in the the real world example, that we could see mm, the state of the charge of a battery that could be varies from 0% to 100%. Actually 100% means the battery is fully uh, charged actually, and the 0% means the battery is fully exhausted. So in the real world example, while we are fetching the the data, and the data could be transmitted over here, that the state of the charge and the power in terms of the kilowatt, the electricity cost and the parking time and the energy consumed that we are having, that we could easily investigate the electric vehicle tariff monitoring the data in a common ThinkSpeak platform, so that the I mean the basic need of the future power system engineers, that while the power system engineers are looking for to investigate the cost of the electricity generated in a particular the modern deregulated environment, in a typical EV integrated infrastructure, they could easily investigate the cost of the electricity generated, and also the different parameters like the real time monitoring of the EV charging strategies, that could be easily investigated in a real time workspace. Now, in the next part, I would like to emphasize especially an architecture of a fuel cell hybrid electric vehicle. Now, basically, while we are having an fuel cell hybrid electric vehicle infrastructure, we must be looking for the energy management system. I mean the EMS. Energy management system of a fuel cell hybrid electric vehicle is one of the major concerns that we do have in the present environmental concept that we are having. And this block diagram is basically comprising of the energy management system of a fuel cell hybrid electric vehicle. As you all know, the fuel cell technology, the hydrogen gas is used in the the fuel tank, and the fuel inside a fuel cell, as you all know, the chemical energy of the fuel is converted into electrical energy, and that electrical energy could be employed to drive the electric the vehicle. In this particular fuel cell the module that we are having, the DC to DC converter could be the implemented over here, the batteries the system over here, the auxiliary system we are having, and the four types of the motors, the motor 1, motor 2, motor 3, and the motor 4. The four motors are basically known as the hub motor or the in-wheel motors. These motors are basically coupled with the each wheel of the the vehicles, so that the transmission losses are basically the reduced over here, and the speed of this particular kind of the electric vehicle is same as that of the speed of the particular electric the motor, this in-wheel motor or hub motor that we are having, and we are having an electric vehicle module that is basically controlling the electric vehicle type train specifications, and a 12-volt the battery system that we are having. So inside this the block diagram, we need to develop the mathematical modeling of each and every subsystem that we are having. And while we are having the mathematical the modeling, the system the representation, or the dynamical the representation of the particular kind of the fuel cell the module, the DC to DC converter, the battery system, energy management unit that we are having, we must be go for the entire implementation. Now, basically the energy management strategy that we are having, every the electrical engineers are basically emphasized, or they must be known that why energy management strategies are so much beneficial. Basically, the energy management strategies are basically concerned with the minimum, the minimum or the hydrogen utilization. So means the lesser amount of the fuel, the utilization, excellent overall system efficiency. This is one of the major consideration as we are having, as because nowadays we are much more the concerned with the energy efficiency. For that, the energy efficient, the devices we must be looking for. And the limited, the range of the batteries is one of the aspect that we are having. The battery capacity is also, the limited, and the extended lifespan of all the, the requirements. So means these four, the beneficial factors we must be looking for to implement the effective energy management strategy of an fuel cell hybrid electric vehicle. Now, while we are talking about the various energy management strategies, as one of my scholar is, the basically working on that the energy management strategy of a fuel cell hybrid electric vehicle, and the upon the different kinds of the control strategies we do have, the state machine control strategy, fuel, I mean the next one is the fuzzy logic control strategy that we do have. And the next one is the classical PI control strategy we are having. The fourth one is known as the ECMS, that is equivalent consumption minimization strategy. And the fifth one is so-called the model predictive control that we are having. So means someone you may have a query that what is the need of this control strategy actually. The need of this control strategy is that to emphasize the effective utilization of this particular energy management strategy. And the part of the controller is basically the heart of the energy management strategy actually. And basically the controller plays a very important role in the sense is that the controller, as you all know, in any process control applications, the control systems is, the basically based on the linear control or the non-linear control that you are having. And with the latest technology, and as compared to the classical control technologies that we are having, different kinds of the modern or advanced control technique that could be investigated as some sort of the model predictive control is one of the the modern control strategy that we are having, that can investigate the future, the data set, and some sort of the controlled and the, the manipulated variable that control system that could be comprising of. And as compared, and one of the fuzzy logic control strategy is also one of the important AI based strategy that we are having. The different kinds of the fuzzy, the rules that could be comprising of. And in this strategy, while we are having the fuzzy inference system, the fuzzy inference system basically comprising of different kinds of the subsets like fuzzification, the interference, the rules, and the deep fuzzifications that we are having, and the different kinds of the membership function that could be taking care in this particular case actually. Here the Mamdani type fuzzy interface system could be taken over here, and the fuzzy logic, the rule base, that is one of the important aspect, that user can choose the different sorts of the fuzzy, the rules that you are having, and the different sorts of the membership function that you are having. Uh, it could be trapezoidal, it could be cat, and Angular, the membership functions, and the different fuzzy rules. It could be 5x5 rules, it could be 7x7 rules that you are having. And fuzzy logic, that we could see that one of the important aspect of the AI technology, and the fuzzifications, defuzzifications, and the fuzzy logic, the rule based. These are the the basic subset of the fuzzy inference system, so the controller can easily identify that fuzzy logic is basically the based on the the binary variables like the 0 and 1. Here the fuzzy plot, the MATLAB based fuzzy plot is basically shown over here, where you could see the the dynamic provided the dynamic the behavior of the three particular parameters are basically taken over here. One is the required, one is the the required power over here, P REQ, the fuel cell or a PFC, and the last one is the state of the charge that we are having. Now we are having the state machine control strategy. It is a one kind of the finite, the machine strategy, and also a kind of the the reactive system that is basically uh, transition from one state into the another state, and using the load power payload and the state of the charge for the bank of the the batteries. This state machine control strategy basically employed to determine the power of the fuel cell, and the obtained the results of the SMC, the method, that is the state machine control, the method is basically employed as the reference electrical power, that is PFC, for the fuel cell. Classical PI control method, as you all know, the proportional integral, the method over here. Here the gain of the KP and KI that we are having, and the value of KP and KI is basically tuned over here to integrate the performance of the PI, the regulator, in a particular energy management strategy that we are having. And while we are investigating the performance of the classical PI control, the method, the different fuel cell specifications, especially power that is low, while the energy density of the battery is higher than the standard, and the battery that delivers all its available power. Yeah, now while we are talking about the MPC, that is the model predictive control strategy that we are having, the system is having the three inputs and the two outputs. That A naught, B naught, C naught is basically the three inputs are basically known as the manipulated variable, and the two are these are two as the control variable that we are having. And it is one of the the model predictive control is one of the modern and advanced control strategy that we are having. And also we could implement the effective energy management the strategy employing the model predictive control strategy. Now, as compared to the different approaches of the energy management strategy that we are having, the basic need of the machine learning approaches is, the machine learning, as you all know, is a kind of artificial intelligence. It is frequently employed in all aspects of the life due to its potentiality to solve the the real world executions. Basically, the machine learning is basically based on the data set. The data set is separated into the two unequal, the groups. One is the main and the testing. Now, the that the data set is employed as input to the specified algorithm during the Hello. Yeah. Uh, in this particular analysis, the machine learning approaches are basically employed to investigate the optimal performance of the controllers. And here the some areas where the machine learning can be applied. The first one is the predictive energy management. The next one is the route planning. The next one is the fuel cell health monitoring. The next one is the state of the charge, that is the SOC estimation. The next one is the performance optimization, and the last one is the emission control. Now, basically, the someone may ask that what is the need of machine learning in this particular effective energy management strategy of a fuel cell hybrid electric vehicle. Basically, the data set is basically requiring the training and testing. The training and testing data set to designate the particular input to the specified algorithm. So in the testing stage, the trained selected algorithm is fed by testing the data set, and the machine learning are challenges are basically classified into three types: supervised, unsupervised, and the reinforcement learning. So there is no one method that can address the machine learning problems due to the simplicity and complexity of the classifications, which occasionally necessitates the adoption of an unique algorithm. Now, basically, here the machine learning strategies, while we do have the machine learning strategies, are basically comprising of the five stages. For an example, the data set. Next one is the training data set. The third one is the learning algorithm. The fourth one is the trained algorithm, and that we could see the next one is the forecasting. So while we are having the machine learning applications to investigate and to forecast the data set that we are having, first of all, in a fuel cell hybrid electric vehicle or in a generalized platform, we need to have the large number of the data sets. That data sets are basically comprising of different fuel cell electric vehicle parameters like the battery voltage, battery current, battery stress, the distance double, the fuel tank capacity that we are having. So the different kinds of the data set that we need to have, that data sets are basically undergo an exhaustive training we are having. The after the training of the data set, we need to have the particular learning algorithm, and after having the particular sort of the learning algorithm, we need to have the trained algorithm. The trained algorithm is basically used to test the data set, and after having the testing of the data set, finally we can forecast the data, or we can predict the data set to estimate the system, the behavior. Here the overall performance of the particular EMS scheme in a tabular format I have shown over here, that we could see that whatever the different kinds of the control strategies that we are having, the MPC control, ECMS, SMC, the fuzzy logic based strategy, and the PI control. In this particular strategy, a comparative statement that is basically taken over here in the real time, the data set, the four EMS criteria like the battery state of the charge, hydrogen consumption, overall efficiency, and the battery stress that we are having. And after having the comprehensive analysis, we can observe that overall efficiency is observed in case of MPC control strategy, as compared to the other control strategy that is having 80.27%. And the lowest, I mean, in case of the battery stress that we are having, that in case of MPC control strategy, the battery stress is having 36.70, and the lowest efficiency that it could be observed over here in case of the PI control strategy. So what is going to emphasize that while we are having the different sets of the data and exhaustive data analysis in the the real world example, and while we are having a comprehensive analysis employing the different energy management strategies, we need to comply with the the performance of the controller, and the two controllers are basically chosen over here, and that controller performance is basically optimized by the employment of the machine learning algorithm. Now, upon classifications of the various machine learning algorithm, some of the machine learning algorithm I have shown over here. I am not an expert of a machine learning. However, a few of my scholars are basically working on the applications of the machine learning applications to investigate the fuel cell electric vehicle performance. And some of the examples of the machine learning algorithms are support vector, the machine SVM, the classifier fusion technique, and the third one is the K nearest, the neighbor, that is so-called KNN, and the next one is known as the naive Bayes algorithm. So means upon classifications of the the different the data set that we are having, we need to choose for the particular machine learning algorithm to predict the future the behavior, and to investigate the different the data sets of the energy management strategy, and also to optimize the performance of the energy management scheme in a modern energy efficient environment. So here I have been shown over here the one the block diagram of the SBA model, that is so called the support vector the machine. In case of the support vector the machine, while we are having the MPC and RBFL, the strategy, actually the rule based the strategy that we are having, and these extraction of the features, the first one is that the feature extraction should be taken place actually, and after the feature extraction, the training system that should be incorporated, and the training system should be incorporated by employing the extracted features. Afterwards, we need to have the SVM classifications that is based on MPC or RBFL, and after the classifications of SVM, that is the space vector the machine, we need to test the data actually, and finally we need to get the extraction of the features that could be investigated using the particular the model that we are having, the SVM. Now in this particular analysis, while the accuracy test is basically accomplished using the support vector the machine, we are having the incremental feature selection, that the features that are basically taken care, the battery capacity and the battery stress, the accuracy is 90%. And the next case, while we are having these three sets of the the data that comprising of the battery capacity, battery stress, and the the range of the EV mode, that gives us an accuracy of 95%. The third one, when we're having the parameters comprising of battery capacity, battery stress, range of EV mode, as well as the fuel tank capacity, the accuracy which gives us the 98%. So that we could conclude that while we are having the an exhaustive analysis of the data set with an incremental feature selection, employing the support vector machine algorithm, the accuracy that could be tested and it could be examined, and finally while we are getting that the four sets of the data, while we are having employing the different kinds of the controller data set, the 98% accuracy could be investigated in the real world examples. Now, one of the classifications is so-called the classifier fusion technique. Actually, the classifier fusion techniques is basically combining the outputs of the multiple classifiers. For an example, the SVM, KNN, and the naive Bayes algorithm, and this could improve the overall performance and also the robustness of the classification tags that also could be enhanced actually. So means the classified fusion technique that could be investigated while we are having the combination of the three classified techniques like SVM, like KNN, and the net bias technique that we are having, and finally the classifier with the combination of the classifier fusion technique, we need to have the decision to characterize the future or the behavior or investigate the data set, and also that gives us the binary variables as the 0 and 1. Here in this particular strategy that I have shown over here, that how the different NET testing could be taking place, employing the different kinds of the selection of the the feature vector. So in this particular strategy that we are having, while selecting the particular optimal features, the nature of the features are basically shown over here, and the battery capacity, battery stress, range, EV mode, fuel tank capacity, mass, actual fuel economy, aerodynamic, the drag, and the slow charge max. These are basically symbolized as F1 to F8 actually, and the different features, the vectors are also basically taken over here in this particular context, and these are the ranking over here from 1 to 8. For an example, the range EV mode, that is F3, that has been taken care. The battery stress F2 is ranked as number 2. Battery capacity was taken as F1 is taken as 3, number 3. Feature vector set. Likewise, the actual fuel economy, the slow charge maximum fuel tank capacity, aerodynamic, the drag, and slow charge max to max. These are basically classified as the the ranking feature vectors. And while we are having the different combination of the features, like F3, we are giving and we are the giving features strategy that could be vector set are basically classified from M, N, U, V, W, X, Y, and Z, and so that we could emphasize that while we are going for the different classifications of the data, and we need to go for the optimal operation of the the data set to predict the different the behavior and the classifications. For an example, F3, the next one we taking over here, the different feature vectors are added over here in a simultaneous manner. F2 plus F3, the next one is the F2 plus F3 plus F1, the next by next, and the final one we are having the F2 plus F3 plus F1 plus F6 plus F8 plus F4 plus F7 plus F8. So means while we are combining the different kinds of the feature vector set, and these feature vector set are basically terminalized as M to Z, in this particular aspect, we are going to emphasize the accuracy of the incremental vector set in this particular strategy. That, for an example, the SBM, the KNN, net bias, and the classifier fusion technique that we are having, and we could easily investigate a comparative analysis of the accuracy that with the different sets of the the machine learning algorithms, how the supervised, unsupervised, and also a kind of the reinforcement learning, whatever the different classifications of the machine learning algorithm we are having. And finally, we need to have the incremental progression of the features with respect to the accuracy, uh, uh, employing the different sorts of the machine learning applications. And finally, these accuracy could be helped us to investigate the particular stability of the particular energy management strategy that we are having. And the accuracy gives us that to choose the particular controller of an energy management strategy that we are having. Now, here in this particular emphasis, the different classifier examples of whatever the MATLAB simulation, training, and testing that could be taking place using the different, the data set in our data set. The 350 number of the, the data sets are taken into consideration to investigate the classifications. And upon these training and testing of these, the data set, we could see the hybrid classifier function is providing the better performance in comparison with the SBM, KNN, net bias algorithm. And that we could see that nearly 98% of these the accuracy, I mean 98% of this accuracy by employing the hybrid classification strategy, that could be providing the better performance in terms of sensitivity, specificity, as well as accuracy. Therefore, we could conclude that the hybrid classifier, the machine learning classification strategy gives us the better performance. Here, one type of the ANOVA analysis, what is so-called the box plot of the feature vector set variables. There we could see that 1, 2, 3, 4 actually. Here we could easily say the ANOVA test is one is so-called the analysis of the variance. It is one of the tests which is basically considering the feature vector set available in the particular, the data set, whatever we do have in this particular context. So this is basically presenting the variance, the results which could be arising within a group of data that we are particularly having. And upon these classifications, we could have, there's the feature number 3 is having the more statistical significance with respect to the other features in this particular context. So means the basic significance is that actually that ANOVA test is one of the variance algorithm, and which is nothing but showing the box plot actually. And that box plot is comprising of different kinds of the feature vector set variables. And whether we are having the different sorts of the the data, and we need to go for the variance to check the variance, the results arising with a particular set of the the data. So these analysis could be helps us to investigate the statistical significance actually, whether we are having the different sets of the the data that we are having. In this particular slide, while I would like to show you that while we need to go for an analysis employing the cross validation method, the cross validation method using the machine learning algorithm, whatever we have been shown, the different subset, for an example, subset 1, 2, 3, 4, that we could see the different accuracies are basically taken place 95, 94, 95, and also 96. And the average, the results on the cross validation, that could be gives us as 95%. And the different kernel functions, for an example, it could be the linear functions, it could be polynomial function, it could be RBF function. So means that the accuracy, that it could be a highest in case of the polynomial function as compared to the linear, the linear and the RBF function. And for the validation of the performance of SVM, especially the support vector, the machines, the performance has been observed over here, the three kernel functions, and these are basically helps us to investigate the accuracy of these, the different kinds of the kernel functions we are having. And this subset of the data gives us to characterize the future behavior or the predictive behavior, or in a using the real world examples that we are having. So last but not the least, whatever we have discussed, the future technologies we need to go for the sustainable development of the environment, that we could see the electric drive train is basically comprising of the different classifications of the electric vehicles technology, like the hybrid and the plug-in hybrid electric vehicle, the battery electric vehicle, and the fuel cell hybrid electric vehicle, hydrogen IC engine. These, this is basically a forum that we are having, and with the CNG, LNG, or either the different, the subset that we had, we must be segregated into these two sets of these strategies, that the future electrified transportation sector, we must be go for the electrified transportation sector. It could be comprising of the light vehicles to heavy vehicles for the sustainable development of the environment. And we need to face for the lots, the lots of these issues, like the charging infrastructure, the policies, like the regulations, like the distance covered that we are having. So lastly, we could conclude that we with these with this uh, with this government, intervention in this particular conclusion, that we must be emphasized that in the 2020, the global electric vehicle stock touched the milestone of 10 million, which is an increment of 43% as compared to the 2019. And the rising number of the electric vehicles is basically the policy measures that is basically undertaken by the government to transition towards the cleaner and more sustainable forms of the energy transportation sector, and to reduce the carbon dioxide emission or the tailpipe emission that we are having. And we could conclude that, as per the statistical analysis, that more than 20 centuries have electrification target, or they will ban the ICE, the vehicles, while the 8 countries and the European countries, they have, announced that the net zero just 2020. But the robust, the network of the EV charging infrastructure, which could be developed across the world to cater to the growing number of the electric vehicles. And India has taken a mission that 33 to 35% by the 2030, which could be, the below 2005 levels, 2005, where the carbon footprint and the summit were placed to increase the share of the non-fossil fuels based electricity could be enhanced by 40% by the 2030. And nevertheless, it is more important for the stakeholders to take the inspiration from them, and we need to formulate the policies and the regulation which are most suited to integrate the Indian electric vehicle, the ecosystem. Now, in the slide, actually, I would like to say a few words about the government intervention. Now, whatever we have been talking, that the topic was so called that electric mobility for sustainable development using AI and ML. So, we, the society, actually, along with the government of India, more or less, the government interventions are much more important to integrate the electric vehicles technology in India. Here we could see the deployment of the high quality advanced, the batteries that we need to have. So means the battery system, the designers, they must be looking for the integral design of the battery so that they can sustain the battery stress, the battery uh, capacity that we are having. And next part is that the different industries, these are basically looking for the private and public sector industries. They are basically looking for to investigate the several kinds of the funds to install the charging infrastructure in the India. And government of India is definitely suggesting and employing the different sorts of the funds and incentives to the different public and private sector agencies to come across and invest some more funding and to integrate the electric vehicle charging infrastructure, and also the financial availability, particularly for the commercial electric vehicles. That is one of the promising solution that we are having as compared to the conventional electric vehicles, as because in a hybrid electric vehicles, more or less, while we are going to have the hybrid electric vehicles, the initial cost or the installation cost of the hybrid electric vehicles is much more as compared to the conventional vehicles. However, the running cost or the the maintenance cost and for the environmental sustainability, that can play a very crucial the role. And last but not the least, um, the information education and communication, that is IEC, on electric vehicles technology, that could be integrated across all over the states actually. And different states are basically uh, planning to investigate the different kinds of the electric vehicles, the manufacturing, as well as to investigate the different kinds of the charging infrastructure for the the countries, the benefit. These are the references from where I have collected some sort of the informations. Lastly, I would like to thank you everyone for your kind presence. If you are having any sort of the query or the doubt, you may ask, please.
Thank you, sir, for your very beautiful session. So, dear participants, if you are having any query, please let us know. If you are having any queries or doubt, any question, please tell us so sir can able to answer on that. Okay, so I hope there is no such any queries from that participant end. Okay, sir. Okay, so one participant just raise your hand.
Yeah. Good evening, sir. There is one query I have. So, sir, in terms of the various machine learning techniques that you discussed today in today's class, and you also talked about assimilation of different techniques, and finally getting a more and high efficient system using a hybrid one. So, if I want to start the analysis, so how can I start this machine learning approach to a particular system?
Yeah, good question. Yeah, yeah. The basically the machine learning algorithm, which is basically based on the different kinds of the the data sets actually. है ना? So whether you need to go for the analysis of the the machine learning actually, first of all, you need to investigate the exhaustive the data set of particular kind of a system that you are having actually. And while you are having an exhaustive source of the the data set, then you need to have the classifications actually. That classifications could be based on the training and uh, testing exactly. So for an example, if you like to have any sort of the empirical the investigation, then first of all you need to fix some particular kind of the data set actually. The data sets are so much vital. So once you have the exhaustive data set of any kind of the dynamical system, then you need to go for the system identifications. The system identification gives you the specific nature of the training and testing of the data. After having the training and testing of the data, finally you can forecast the behavior or the performance of any kind of this system.
Okay, sir, and in the same regard, in one of your slides, so
Yeah,
after that trained data set, you mentioned about then we'll have a, algorithm, and
yeah.
in the next step we'll have a trained algorithm. So
Yeah,
based on this entire flow of methods and steps, finally we'll get a trained data.
yeah,
Likewise,
yeah,
okay,
yeah, yeah, yeah.
fine, sir. Okay, sir. I'll try to study
Okay.
in this
Thank you.
field.
Thank you.
Thank you, sir.
And thank you for your query. Is there any other questions or query? Okay, so I hope there is no other query from that our esteemed participants. So thank you, sir, for your uh, brief descriptions as well as your beautiful sessions. And you are giving a lot of results and their studies and how we are going to implement with different algorithms. I hope that is really important for all of us to implement and understand the real-time problem dealing with some EV related issue. So thank you, sir, for your participations as well as studies. Thank you, sir, for your lecture. Okay, sir. Thank you.
Sir, I would like to add one point that
Yeah,
since
please,
you
please.
started with e-mobility and sustainable part, so I thought like in the end I'll definitely ask about sustainability. But you started your session with the same thing, and you discussed almost everything, like how we can make this situation better with our country's perspective, and how in other countries they are doing these things. So
Yeah.
that also is very inspiring uh, to
Okay.
uh, to people who are interested in EV research actually. So thank you
Yeah.
for that. Yeah.
Thank you. Thank you. Thank you. Thank you much.
Thank you. Okay, so the session is really very, it's good and we are able to know a lot of things from it. Okay, thank you, sir.
Thank you.
So now we
Bye.
are going to conclude the session. Okay, sir. Bye, sir.